Okay, so we're going to have a look at the lab colour format and the advantages it can offer us. So lab is based on colour opponent theory, and unlike the RGB colour model, which uses additive values of red, green and blue for its final output, lab is instead based on the human perception of colour. So let's jump straight in. So we'll convert this document to a lab colour format by going to Document and Colour Format, then choosing Lab 16-bit. And you'll notice straight away here we've gone from having red, green and blue colour channels to instead having lightness, A opponent and B opponent. So lightness is comprised of monochromatic image information and the colour comes from A opponent and B opponent. But before we jump into working with the channels, we can do a very simple demonstration of the differences between RGB and lab. If we go to Select and select Sampled Colour, we can choose to sample the reddish tone on the castle wall here. Now that's an RGB model selection of that colour with a 15% tolerance. So it's basically selecting that RGB value with a certain threshold of pixels that are greater and less than that same RGB value. If we switch to lab, however, you'll notice we're selecting a greater amount of pixels now. This is because it's now looking at what is perceptually close to that colour, as opposed to just looking at raw RGB values. So now, for example, we can reduce the tolerance to create a selection of most of the red tones in the sides of the castle here. If we switch back to RGB, you'll see we're not actually selecting as many neighbouring tones, especially in these parts of the image. So I'll just switch back to lab, and as you can see, the neighbouring selection area has increased. So then what that basically means is that we can use the lab colour model for more accurate perception-based colour selections. But lab has got some other benefits as well. So if I go in and add a curves adjustment, you'll notice from the channels target here, we can target lightness and A and B opponent separately. So unlike RGB, where to alter the overall brightness and contrast of the image, we would have to modify all three channels at the same time, we can instead target lightness and then draw our nodes onto the curve, as we would usually. And you'll notice it's only affecting the lightness of the image. The colour information is remaining untouched. And this is incredibly useful for low light and urban photography, where you might be dealing with a lot of mixed artificial light sources. So further to that, we can go in and target A opponent. And what we can do with these two nodes either side to begin with is just bring them in, like so. Move across to B opponent and do the same thing. And you'll notice we're actually increasing the intensity or the saturation of the colours here. But just by creating very small differences between A and B opponent, you can vastly alter the tone of the colour in the image. So again, where this would come into play, especially would be with mixed lighting, where you might want to get rid of or introduce a certain colour cast or colour temperature. So here, by creating a small difference between A and B opponent, we've really brought out these reds and greens and made the colours quite vivid. So then, this is a bit more of a niche use for this, but because we can edit channels individually, that means we can apply filters and effects to just the lightness channel, for example. So I could go ahead and select the background pixel layer here. And let's say I want to add some sharpening, but you'll notice we've got some chrominance noise around the image and also some fringing around the edges of the subject. So let's go into Filters, Sharpen, Unsharp Mask, and we'll introduce a radius of about 1 pixel and drag the factor slider up, just to exacerbate this effect so you can really see it. So then, we're also modifying the color channels, and we're making this chrominance noise a lot worse, in addition to exacerbating the fringing around the edges here. However, if I choose to only edit the lightness channel, and I can do this by clicking the two pencil icons for A and B opponent, you should notice we're now only sharpening the lightness channel. And so we're leaving that color information untouched during our unsharp mask operation. If I just reset this so we're editing the color channels as well, you'll see by editing A and B opponent with this unsharp mask, we're also introducing some degree of color bleeding as well. So once again, I'll just take A and B opponent off. And yes, the difference is small, but it just gives you that extra flexibility and control over which channels you want to apply filters and effects to. So I'll just pick a more realistic value for this and then click Apply. Additionally, if I go ahead and reset these, and then we go into Filters, Blur, and Gaussian Blur, we can drag the radius up. Then we can choose not to edit the lightness channel, but rather just influence the A and B opponent channels. So you'll see here we can then gradually blur the chrominance information, and this can help us take the edge off that fringing we were seeing around the edges of the building here. And you can also use this to reduce moire in images. So for example, if you're grabbing stills from video sources. Okay, so hopefully that's given you a couple of pointers about editing in the lab color format. Do bear in mind that working in lab is computationally more expensive than working in RGB. So just be prepared for operations to be slightly slower than if you were working in RGB. Thank you for watching.